The first thing is that check for the missing value. You must look at it visually, look at that data. Where is it? Do I have missing value? And I've told you how to detect the missing value. Okay? Now, the next one is a check for outliers. Okay, check for outliers. Do you have a data that should be beyond the normal? Now, the next one is a established type of data in the case of categorical data. Check what type of data it is. If it's in the case of categorical data, then you have work to do to convert them, to make them comfortable for machine learning to give you the output. The last one is that do what you call feature scaling. In other words, normalize the data or standardize the data. You have to do that. And lastly, you store the pre-processed data. Now you store that data for now further application with machine learning. I follow. Those are the 4 processes that you must undergo. Now, I've done a template for you. Look at that last side. Look at this template. Open it. It's a step-by-step of everything we've done today and the output. Play with it. Use your data. If it gets stuck, come around. Okay? I will find a way to help you. But you buy me a bunny bread, but it's okay if you don't come. Okay. Now, also, all the functions that we've used in this work, they are all here. You see that 2 functions that we use to convert, to make them to be 1, they are here, okay? And these are all the data we've done, we've used, and this is the folder that we've used. That is all the lecture for the lecture 1. And I'm sure that you'll be able to do your own pre-processed data now, okay? We are now going into the first lecture of machine learning, and that is KNN. Okay, now open your lecture note, your folder. Let's close everything because we are starting a new thing. Go to your student lecture, go to KNN. Now, let me make you to be happy first. Make you to be happy in the sense that go to KNN papers. What I've done, I've downloaded various applications where you can use KNN. And if your own is not there, just tell me my own is not there. Okay? Now, look at where, because I want you to be able to write paper after this class. You just take your data, you plug it into the code I'm giving you, you will see how smiling that result will be. Okay, now let's just look at it. I'm just going to make it quick. If somebody is working on stock price prediction, you can see stock price prediction using k-nearest neighbor is there. And I'm going to write the code. You just pass your data through it, you'll be able to write this paper. Cheap as easy. Now, are you with me? You see that everything. Now look at this. This is a short-term rainfall attenuation prediction. They use a k-means there. Predicting the stock price trend using k-nearest neighbor probability is also there. Improving k-nearest neighbor efficacy for the fuzzy text classification. If you do text classification, you can use it. K-nearest prediction analysis of stock and share closing price. Bank credit risk analysis with k-nearest neighbor classifier. A case of Tunisia Bank. I think, Prof, where's your student that was doing something on bank or something?
Yeah,
is she here?
Zimbabwe, she couldn't find.
No, there's another lady who was working on
the what do you call it? The credit.
Is she here?
Yeah, Utmelo.
Utmelo. Oh, okay, good. Did you see this? Can you relate with it? You can relate with it. If I give you the code today, you'll be able to give me this paper. Huh? Utmelo. Now I'm asking you because I'm putting you under demand now.
Yeah.
I'm going to put you through today, and you must get this out for me. Huh?
Yes, I say yes for us.
Stock price prediction using modified k-nearest neighbor algorithm. A cooperative study of supervised machine learning algorithm for stock market trending prediction. I think there are a few people who are doing stock market. Who are doing stock market? Yeah. Who else? Somebody okay. Apply K-nearest neighbor in diagnosing the heart disease patient who's in the heart disease. You use this method there. You just pass the data into it. You get yourself one paper. Diagnosing of cardiac asthmatic using a Canet difference weighting KNN. You can see the applications of what we're about to do now. You see, this is a journal, K-nearest neighbor method of analyzing the ECG signal. Who's working on ECG? There's one student working on ECG in our department. You can use this one. Easy. A framework of heart disease prediction using K-nearest. Stock market prediction using the K-nearest. Discrete K-nearest neighbor sample for simulating multi-precipitation occurrence and model adaptation of climatic change, if you are working on climatic change. Application of weighted K-nearest neighbor algorithm for short-term load forecasting. That's if you are working in power, solar, winds, energy, all those stuff. Application of K-nearest neighbor approach for predicting economic event, theoretical background. Predict the trend of stock price using machine learning. A review of data classification using K-nearest neighbor. A comparative study of heart disease analysis using classification techniques. Performance evaluation of data mining classification technique in heart. I have a lot there, and it talks to different fields. Sentiment analysis, a lot of things are there. Now, I'm going to walk you through the whole theory of it, and I will take you through the simulation. You just take that simulations and play with it. But when you write the paper, remember me. Yeah. Don't take my brain for granted.
There's no free. There's funny, so do you deny?
Oh, okay. Therefore, and I gave you all the entire paper. If you open your folder, did you see the papers are there? Just look at it and write the conference at words. The conference at words. Therefore, I'm not demanding for big things. At words. Therefore, all the different types are there. Classification of heart disease using K-nearest. Heart disease. A statistical approach for rain intensity differentiation using a metro site or something like that. You can go on and on and on and on and on and on and on. There. Okay, now let me put you to understand this. Let's start with our lecture on K-nearest neighbor. Now, as I've told you earlier on, let me walk through. When we talk about K-nearest neighbor, let's look at the entire machine learning. As I've checked earlier on, I've explained to you that we have a supervised learning, unsupervised learning, and reinforcement learning. There's a semi-supervised learning, okay, where your deep learning fall into basically. Then under the supervised learning, you have your regression problem, which Prof told you earlier on, and classification. You can do two things under supervised learning, which is your regression problem and your classification problem, or your predictive problem. You can do them here. Under unsupervised learning, you can do your clustering, anything clustering problem, you can deal with it using unsupervised learning. And you can also carry out what we call a dimension reduction when you apply unsupervised learning. Now, what do you mean in a simple sense when you say dimension reduction? You have 100 input and you have one target, for example. It's not all the features of the 100 input will contribute with the weight that Prof was talking about to your output. You know, you have some friends, they are damagers. There are friends, they are good ones. Now, the friends that are not good to contribute to your life, you use what we call a dimension reduction factor to cut them off. You only use those friends to give you output. Do you get it now? That is where dimension reduction comes in. A good example of it is your principal component analysis. You use that to silence the features that are not giving you a reasonable output when you put the whole weight together. Are you following? Then, under that, we will deal with this toward the end, which is the last lecture I promise you. It's a whole day lecture. We'll deal with clustering problem and dimension reduction. I will teach you, then we apply it to a real problem. Now, I will use one of my student case study to do it, where we use it to detect the virus and all those things on the system. We combine these two together to get a very good result, and we do it here in the, but don't write anything on it because he has not written, because I just want to do it with him. Now, I want you to put it in a very graphical form. What does this one say? When you have a supervised learning, you see dark, rabbit, dark. Then you carry out a supervised training. Then they will give you what you call a predictive model. You take a predictive model now. The day the chicken comes, you pass the chicken through the predictive model. Then it should be able to detect, because you've run all the data related to this in it. Then you use that model to do that. But if you notice, in the case of unsupervised, what do you notice? There is nothing that is training here, basically. All of them, they come together, but based on their pattern, they're able to cluster themselves into group. Are you following? They just cluster themselves into group. They are not classified. They are clustering. Now, they look at the pattern, okay. They use the sound to say, okay, I belong to chicken. I belong to dog. Hey, I belong to dog. Now, they use that now to do what they call clustering. Now they cluster themselves into different. And that is why unsupervised learning is used for clustering and dimension reduction. Do you get it? Now, dimension reduction in the sense that if we find an animal that doesn't have a total attribute to contribute to this group, we need to cut them off, so that it makes the cluster to be clean. Do you get it now? That is why the two area of application become useful in the case of unsupervised learning. Is that clear? Now, having said that, what topic do they cover? When you look at classification, you see other classification, other supervised, we have classification and regression. Other classification, you can use support vector that Prof talked about, the discriminant analysis, the naive Bayes, nearest neighbor. All these we are going to cover them. We will simulate them with the problem. Now, regression, we look at different types, but under that we only go to deal with example. I will only deal with example one. And this short tree, I've done neural network with the PG student. I can give you the note. Here, under the clustering, under the supervised, we will deal with K-means and we will deal with Arachika. Then I'm not going to deal with Gaussian mixture or the ED Markov. No. I will find, if anybody needs it, I will find time. Now, let's start with this. What do you think is happening here? Do you see here, we have banana, we have everything. Now suddenly, all these are into different classes. They are in a group. Now the question is that somebody bring potato and say, I am potato. Now, I am a potato, where should I belong? Where do you think they must belong? Somewhere. Where is this potato going to belong? We don't know. But the attribute we are looking for the sweetness, and we are looking for crushing. And now, out of all these two attributes, where do you think potato will run to? Do you get it now? Now, that's why I say, what is this? What do you think about this? The other problem that I want to show you is the sweetness and the sourness. We have this particular 3 groups. Now suddenly, I don't know the name they call this fruit. What is the name they call this fruit? Because we don't eat it in Nigeria. This one that looks like this. It has something, I don't know, but let's keep the English. Fig. It's a fig. It's a fig, okay. Now, where do you think? Now, he's looking for where he's going to belong to. We don't know. Now, okay, let's do it this way. We are all here now. We have a clustering of boys, of girls, of differentness. Now suddenly, my daughter just entered this room. She needs to belong somewhere. Where do you want to belong? Put my daughter. The only characteristic she has is she's dark. That means it's in the group of the black group, isn't it? Yeah. Then we're able to class her into a certain group. Now, the same thing is what is KNN. That's what they do. Do you get it now? K nearest neighbor. That is what you do. Now, let's do real illustration around it. I have two different categories. Categories 1, category 2, which is class A and class B. Now, these two classes are in existence. They are existing. There's no doubt about the attribute they have or feature they have. Suddenly, somebody comes in, or no person comes in. Now, I want to be able to position this person to either class A or class B. Now, for me to do that, there are few things that I need to take into consideration. It's based on 4 characteristics that you need to check. The first one is that you choose the number of the K nearest neighbor. What do we mean by that? What is the number of K nearest neighbor? In other words, I have this person like a star here. Who are the neighbors to this? This is a neighbor, this is a neighbor, and this is a neighbor. I can still say this guy is a neighbor. I can even say this guy is a neighbor. Now, you need to make a choice of appropriate neighbor that will be able to have influence on determining this person, the characteristic of this person or this picture, so that we'll be able to put the person in the right place. Now, for us to do this, the first thing is that we need to determine the K. If I make a room, if I make a circle, this is 1, 2, 3. Then my K is what? Is 3. If I open up my cycle and say, I want to include people in this place with it, that means I have 1, 2, 3, 4, 5, 6, 7. That means I have, 7. I have 7K. That means my K is 7. If I open up again, let's say I open up this way. I have 7 already, 8, 9, 10. Then I have 10. Do you see it now? Now, I need to know how many neighbors are available. The next thing is that I need to compute what they call compute the K neighbor of the new data according to what the distance measure of that person, of that entity. Now, what does that mean? I'm going to say, because the object is here, what is the distance? What is the distance? What is the distance? If I take 3, for example, what is the distance? Now, how do I determine the proximity of where the person is close to? Prof told us earlier on that you use what you call Euclidean distance function to achieve that. There are other methods we can use, which is Manhattan method, isn't it? Then we have a Minkowski. No, this one is difficult, Prof.
Minkowski. It's a combination of the other two.
Yes. Now, when we get to MATLAB, you are going to see, I'm going to introduce you to another 7 functions you can use. Now, I want you to now be thinking, if I have a paper that uses Euclidean, can I carry out a performance analysis on the best distance method for my problem? That's another paper. Don't you think so? You play with all those functions, you see how easy it is. You just change one line, you run it, you run it, you run it. Now you produce a paper. Now get me right, you will see how you play with the code. Now you have that. Therefore, this is a key to you. This is a key now. Just keep your mind. The distance is a key to you. That means that I have computed the K nearest neighbor of the data point according to the same distance. Now we decide to use any of these, but I'm going to give you 7 more of different distance to use. And the Prof said earlier on, it depends on what type of data it is. Is it categorical? Is it ordinal? Is it numerical? Therefore, the Hamming distance method is normally used for categorical. When you include the method, tends to work for all of them. Therefore, if you play with all those things, you will see how reasonable result you are going to get. And I just put the formula there for you. Do you understand now? Now, let's see something very interesting. Okay, do I finish that side? I will think that. Okay, the next one is that count the number of data. Count the number of data points from each category among the neighbor. Now, if you look at this, if I look at this, how many data from this category? 1, 2. That means I have /2. How many is this? Is what? /1. Are you with me? Now I say count the number of data points from each category among the neighbor, compute in step 2. Now the next one is that the new data point is assigned to the category with the most what? Neighbors. That means, where do you think this person will belong to? This family. Because it has the highest neighbor. Do you get it now? That is what you call K-means. It's as simple as that. Do you get it? Now, let's make it a little bit interesting. Now, look at this data that I have. I have about 6 points. Suddenly, somebody puts a point or no point in this place. Now, when I draw this, the closest one are these two categories. These categories. My question to you is that, how many neighbors are here? There are 3 over 3. Here is what? 0 over what? Over 3. Which one do you think this particular object we associate with? Which one?
The first one.
Associate with. Do you get it? That is your nearest neighbor. Imagine I gave you a data of height, ID, and age, and I gave you the weight, and I don't know this data 11. I don't know which weight is that data, this thing we have. What I do is that I plot the two-dimensional graph, the height against the age. I look for the height for the ID one. Where is the ID will be? I look for that 5. You see, ID one will be around 5. Where is that? Age, that's the height. It's around 5. Let's see, around here, isn't it? Then I look for age 41, 45, around that. ID what? It's ID one. That's why that place is marked. Do you see that? Then you do the same thing, and when you get here, you do the same thing. That's why you see 11 falling at this point. This is where your no point fall into. Now the question is this: which one am I going to associate this object to? Am I associating this object to this or here? That is where you carry out the distance, carry out the number of K, and you determine what the neighbor where that particular object. Now let's play with it in terms of code. Okay, let's go to our MATLAB code. Do you understand? Is that theory clear? That's what we want to do. And now, what in your mind you should be thinking, where can I apply this to my work or to my data? Okay, now let's start a new journey. Now go to your MATLAB. I said that, remember this particular slide that I have here. This slide that I have here is the last slide that I discussed with you with the data. The first thing we are going to do a pre-process of our data. We have our data here. We have our data already. Your data is the one here. Can you open it and save it? That is your data. Do you see that data, everybody? Okay, thank you. That is your data. I want you to save that data. Save your data now. This is the data, is the same data in your folder. Did you see that? That's your data. Now, remember, I want you to do this. Open this particular pre-process template. You will see pre-process template. That's what we are going to be using. And I'm going to explain them one by one. Remember, the first thing we are going to do is to pre-process the data. The same thing with your research. You have a data now. We want to determine the first machine learning on that data. Are you following me? Now, the first thing is that we have to do pre-process first before we apply the machine learning on it. You will see how easy machine learning is today. Yeah. And you will hate people who talk about it. Don't hate Prof anyway. You must like us. Now, let's start with this. Open this because we are going to be using that. Remember, there are 4 steps I told you from your slide. Go back to your slide. First of all, check your data in the following order. Check your data in the following order. The first order is that check for your missing value. Check for your missing value. That's the first thing. The second one is that check for your outliers. The third one is that establish the data in the case of categorical. The fourth one is that do feature scaling. And the last one is that store your data now as a new data for you to continue your machine learning on it. Do you get it now? Now we are going to carry out the 4 on this particular data they've given us. Now, you have the data already, isn't it? And it's in your folder, is that correct? Okay, now open this that you have. Remember, the first thing is that we need to import the data. Yeah. Import the data. That's the first thing we have to do. Okay? Copy this. Everybody, copy from here to here. I've taught you how to import the data. I've taught all of you how to import the data. Okay, copy that. Open a new notepad. Close your MATLAB, let it be new. Okay, now open a new notepad on your MATLAB. Now paste it there. Let's first of all load the data in so that we can start the pre-process. And make sure you do it on 2019 anyway. Just clear your workspace, clear everything. I don't want to see anything on your system so that everything look new. Delete all this, they must go. We don't need them anymore. Close all this. No. No. Close everything first. Close everything. No. 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 Make sure you close everything. No. Okay, that's fine. Okay, now the first one is that we are going to do a data pre-process, okay, which we've copied now. Okay, now what I want you to do now is I want you to copy remember your data now, go to your folder where you have it, import that data. Remember, this is data you want to import, right click, go to property, copy the security, go there and copy that. Okay, take that and come to your MATLAB again. Are you with me? Then replace this. Replace this with yours. Have you done that? Okay, we've replaced it. Now I want you to roll it out and say, yes, let's see. Now he has done all the data. Now he has imported all the data for you. Yeah. Remember, we said what we have to do now. What do you think we have to do? We have to do the first thing is that we check for missing value. We are going to check for the missing value from that data, especially the numerical data. You look for that. Can you check for the missing value? Everybody look at it. Is that a missing value? Do you see any missing value there? The first thing is that you use your visual checking. Do visual checking on that data. How do you know you don't have it? Okay, you check for the missing data. Can you use a MATLAB code to check now for that data? What do you use? Is missing data. Is missing data. Pass it now and let's check. If it returns 0 to you, it shows that there is no missing data. If there is any 1 indicated, it shows that is what? There's a missing data. Let's pass that command. Is missing data. What did it return? It returned all zeros to you. Did you see that? Now, let's say you have 1 million data. Will you be able to see all the zeros? You can miss 1 in between, isn't it? Now, what do? You use the word sum. Use the word sum. You pass sum into what? Is missing data. Then you close the bracket again. Come on. Now, did you see what it returned to me? It returns 0. If I have 1 million data, if there is 1 in between, that sum will make me to see. There is 1 that my eyes cannot see. Did you see what I've done now? Did you see that? The first thing is that pass is missing data. Pass that command instruction. What it will do is that it will find. It must return all 0. If it doesn't return all 0, it shows where it give you 1. There's a missing data there. This data tells me there's no missing data. Then you pass the sum so that you can have the summary of it. Is that okay? That means the first question, is there a missing data? We've answered it. There is no missing data. That means that code, that section of the code is not valid for us. We don't need to do that pre-process for that data. Do you get it now?
Yes.
Everything I've taught you initially is the entire pre-processed data it's a pre-processed data process. Are you following? What I'm now doing now, I'm now taking a problem. I'm now applying that theory. That shows that all the pre-processed techniques that I've taught you is not applicable, it might not be applicable in your data, but if anything going to be applicable, you have a subset of the solution already in the template. You just come for the template, you apply it. If it's not necessary, you comment that template of that section of template and you move on. Yes?
So in your writing of your paper, in the area of pre-processing,
you explained that.
As you mentioned the steps to say that.
Yeah, you explained your pre-process. Prof said it last time, the first time you lecture here on this area. There is a need for you to explain what did you do with your data, because that you are using somebody's model, and now your performance is low. You don't know the computer those people use. Maybe they use monster computer with high processing power. You are using a Sahara computer, and you are getting a useless answer. Now you are beginning to hate yourself. Now when nobody sees you, you quickly change your own performance as well. And you say you get 0.96559 because nobody sees you. But you need to explain what did you do.
Like from a tool perspective or from a are you going to be explaining it from a tool perspective or general you say that?
You know, whatever you take that affect your process, it needs to be in your paper. If you say you do your process with Nigeria Magic, say it there so that they know that the result you are getting is from Nigeria Magic. So that when they are doing their work, they go to Nigeria and use the magic there and and try to check if your result is okay. Prof, I want to crack joke with them. There was a professor who his father was an herbalist, and the father gave him the power that if you use cutlass on him, you cut him like a cutlass, it won't come inside. And he wanted to write an article on that because it's an African magic. Now he wrote the paper and he said the experiment cannot be conducted in the lab. In the day of presentation of the paper, it will be tested. Then he went in with cutlass. When it was presented, everybody was excited. They want to see it. Because it's a result he cannot present anyway, but it's a result he can discuss and demonstrate it physically. Then he was presenting the paper, the magic behind, the power that you can use cutlass to cut human being and he will never cut them. And everybody was amazed. But the question is that where is scientific proof? that the process that put the bulletproof or cutlass proof in your body, nobody can find it. Anyway, that's African magic. But now, do you get it now that we find the sum and there is no missing data? That means we've answered question number 1. Now, what is the next question we need to answer?
Outliers.
Is there any outliers in that particular data? Now, the question is that, how do you determine the outliers? The first thing is that you know the range of your data, the upper range and the lower range. You have it in your head. Any data that shoot out of that, within that normal, it shows is what? Is an outlier. And you use the plot to detect it. You use the plot, you plot the data, okay, let's do it. Plot the data of your interest, okay, to determine that. You use this, just plot, take a plot, you plot the age, just take that, plot the age. You use plot, data, and age. Okay, let's close that. Now, what you will notice here is that if you look at this particular data, look at the range, you could see that the maximum, it doesn't shoot above 60. It shows that data is within the bracket that is expected. But if it suddenly shoot above, if any of that particular graph is out of 60, there's something wrong with that data. There's outlier in that data. Okay, now you do the same thing for the other data so that you'll be able to detect what's actually wrong with that data.
But Prof, can you choose the type of plot you want to?
No, you can choose it as long as you can see there's no outliers in your data. All you don't want to see is that the maximum data point is 60, suddenly you see 1,000. And that 1,000 is only graph that shoot up, that stay there alone. There's no reading, like an average distribution of that data. It shows something is wrong with that data. You need to deal with outliers. Now the question here is that, do you think there's outliers in this data? No. If there's no, then you don't need to carry out the next operation. Do you understand the practicality of what we are talking about now?
So say if there's no outlier, must you put that graph to say that I don't have outliers?
No, you don't need to put it in your paper. You just say you've carried out this particular process and you detect there is no outliers in this particular. Okay, there's no need for you to say that. There's no need for you to put the graph. Now, this is the next one, which simply tells me the estimated salary range which we have. Is that clear? Do you all get it now? Now, the next question is that, what is the next question?
Type of data.
Sorry?
Establish type of data in case of categorical data.
Now, the question is that, do you see categorical data in your input data? Your input data are two. They are your age and they are what? Your salary. Are there two of them? Are they categorical data? Are they categorical data, Baba?
No.
No. The only one that is categorical data is a target. Do you get it now? That means the two are not categorical data. That means we don't need to carry out the process also for categorical data. Do you get it now? But in the case that you have a categorical data, that means the process on the template, you have to carry it out. You have to do it. Now, the next question there is that, is there a need for feature scaling? Look at that. What determines feature scaling? You remember, what is it? If there is a huge range between age and salary, do you see that in that data? Is that a huge range? Yes or no? Yes. Good. Otherwise, if you don't say yes, I will tell you to forbid the prof lunch, so that we show that we just eat food, we don't get it. Now, there is a need for feature scaling because there is a wide range. That means in the template that I've given you, we are going to work on the feature scaling. All other ones will comment them. Remember, the only thing that won't have a comment now is import the data and the feature scaling out of the template. All other side will be commented. We don't need to execute them because there is no operation of that. in the process. Did you see the way I made the template for you?
Yes.
That's why you'll be guilty if you publish a paper with this thing and you don't put my name, you'll be in trouble.
That is
Now, let's now work on that to see how we are going to deal with that. Now, if you look at your slide, you could see that what I've done is that I don't use a normalization, I use a standardization. And I've given you the reason why I decided to use that. But the two codes are there. What you have to do, you comment normalization and you allow the standardization to be executed. Let's play with it and see. Let's go back to our code. Now, what are we saying? Under the data processing, we don't need to, there's no missing data. There's no need to, we don't need to do this, we need to comment this. Are you with me? There's no need to put a replacement, but there's no need for outliers, am I right?
yes.
Then we should go on. Then, is there a need for categorical?
No.
No. Then the question is that, is there a need for scaling? Yes. Because I don't want normalization, I only want standardization. I'm going to leave that. I'm not going to comment that. I will remove the comment. Just remove the comment. Do you see the template? What I'm doing?
Yes.
Okay, now, what I'm going to do, I'm going to copy from here. I'm going to copy the entire process. Let's do this. I'll copy up to where I import because I don't need to do the import anymore. Yeah, I'll copy up to here. I'm going to put it to continue with what I've done initially. Look at it. Are you with me or you lost?
No, we are together.
Yeah, you are there. You see now I've pasted it. You see I've pasted everything there. I've commented all other one. They are all commented. You see, the only one that needs to be open for me not to be commented is what? Which one?
Feature.
Is this. Now, I need to standardize the age and I need to standardize what? I need to standardize the age and I need to standardize what? Annual salary.
Yes.
2. Are you okay? Okay. Now, you can look at me now what I'm going to do because I need to standardize this, the age, then I need to standardize the annual. I will put the paste. Now, if you look at my data, look at what I'm going to be changing here. Just look at how friendly all these things look like. I've done the age is here already. There's no, the age is there. What is remained is estimated salary. Now, wherever you see the age, what do? You
replace.
Yes.
Thank you. And you're a good copier. Just replace this.
That's why I passed.
Yeah, just replace this. Replace that.
Yeah.
Are you with me?
Is it?
Just replace that.
Yeah.
Just replace that. Just replace that. Do we have anything left? Yes, here. Replace that. Then replace that. Okay, what do you think we have left? Everything seems is in order. Okay. Okay, can we roll it now? Okay, roll it now. Okay, brilliant. See, everything has been standardized. Yeah, everything has been standardized.
Like this. Run it.
Okay, are you okay there?
Yes.
Okay, good. I want you to go here to. Now we want to start our modeling now. We want to start our modeling. Okay, now the next thing now is that we want to now build our model. Remember, you will just smile as how easy MATLAB made most of machine learning model to be easy. Now, remember we've done all the pre-processed data is headed now. We're done with it. Now we want to build now the model. What I want you to look into is that there's only one line of code with the model. You see this? FITCKNN. I want you to pay attention here. This is the only thing you'll be changing all through, and things will be changing as it is. What this means is fit, classification, K nearest neighbor. Did you see that? Now, with this template now, I want to do naive Bayes. I want to change I want to do another classification method. This will be retained, classifier will be retained, it will be
NB.
And what?
NB.
Thank you. Then you run the engine, it give you another paper. Then you change this again, it give you another paper. You see how easy MATLAB is? I'm sure you hate me after today. This guy don't come to class anymore. He has told us everything.
It's easier than R.
I'm telling you, as I told you, when we finish here, all of you go out there and start writing. Now, you will see that's how easy the whole process is. When on your support factor, you are writing millions of code, you will smile. We just change, you see this side, we just change this too. Alphabet, ding, ding, ding. You run it, it produces for you.
Could you do ANN like this, sir?
Huh?
You are doing ANN.
If I what?
Do ANN.
Yeah. But I've taught you ANN already.
How do we?
Okay, now, let's start playing with it and you start seeing the output anyway.
But before, you said after you pre-processed, you must save it as a pre-processed data. But I don't see where you call it.
Remember, it's saved now. I mean, save into any directory you want to do it.
Yes.
In this case, remember we are still computing it will continue. It's in our, if you come here, your data is saved here. That's your data. It's kept there.
Ah.
Yeah, it's there. It's just like I didn't run it. If I want to save it to hard drive, that's the purpose of the last stage. Store it somewhere for you to further use it. That's what I mean. Are you following me now? Are you okay? Can we continue?
Yes, we can continue.
Now, what I want you to do now, open another one here. Okay? Now go to your slide. Now open this. Okay? Copy everything here. And I want you to copy it down. What I want to do now is to explain. Copy it down up to the bottom.
So everything.
Yeah, everything. Now, this is a template that I've prepared for KNN. Now I've combined the data process, I've combined everything, it's there now in that particular folder. I want to paste it on another side. Now, the only thing you are going to do here, is to import your data there.
Prof, I'm lost. Where
which
did we
one
get
is-
this file?
No, look at your slide. You see here, under build KNN. That's like that folder.
Under?
That's the file. Did you see that? On your slide, you see.
Yes,
Yeah.
yes. Now we
Now
see.
open that folder.
Yes.
Now I've now joined the pre-processed data with the building of the code. Okay, but now I'm going to explain to you. Now what you're going to be changing, I'm going to point to you, but I'm going to explain the entire script to you so that you have understanding of how all you are going to do for the rest of your life is to be changing. I will tell you where you'll be changing and how result will come. All the adding, I've done everything, all the adding is there. Now, when I finish now, I want to go back to the paper. Now, go and look at that paper one by one and see the result we get and see how you now begin to write your own. Okay, now, copy that now, and come here, paste it. Now, what you are going to change here is only here. Okay. I want you to change that. Take your data, import your data now. Go back to your data. Where is that folder? I want to import this data. I'll go to property. I'll copy that. Then I'll come to my MATLAB. Just watch me now. Then I'll replace this. I'm going to replace this my data. Remember, you've done all the pre-process. Then I replace that. Okay. Now, look at all my pre-processed data. Remember, the only one that I'm interested in is what? Can you remind me? Standardization, right?
Yes.
Good. I'll go to where's the standardization now? Those are the two. You see, I've opened the standard. Do you see that? We've already done that, isn't it? Okay, brilliant. Now, I've commented all other one. Now, when I come to building my data, see what I've done? My code is this. That is the only function in MATLAB that I need to change, depending on what kind of classifier I am doing, I'm working with. Are you following me? Now, once you do that, remember, my target with my data is what? My target is in that data, in this particular, where is it now? Let me just open this. Let me use this first. So that I can use to explain to you. Now, if you look at this data, what you see here is that I'm passing the age and the estimated data. Are you following me? My interest is to determine if people with this male and age will be able to purchase, they have a purchasing power. I want to predict if they will be able to buy maybe a car or a house. Like in your own case, Prof, what is your student name? Sisi? No, not Melo. Yeah, look at me, I'm explaining something now. In your own case, your interest is to predict if somebody will pay back the loan. Am I right? Now, the attributes are here. What are your attributes? Can you tell me? Tell me your input to predict somebody to be able to pay the loan. Salary, the credit, age, am I right? All of them are here. All of them are here. All of them are here. Now, pay back. Hey, this one, because he's boy, he cannot pay. Because he's old, he cannot pay. That, all of them. Now, you input this now into that machine. Did you see what I've changed? Tumelo? Did you see what I've changed now? I want to go and do the same thing for me. And
so you need to know the predictor variables.
Of course, your predictor variables are here. not purchase, purchase, not purchase, purchase, ability to, you have that. Do you get it? And you have your input variables, which are here. Salary and age. It can be, I don't know that thing, race, it can be whatever. You can have all those inputs. You just do that. I follow it now. Now, what we want to do now is, we've done that. Can you see now we standardize?
Yeah.
Then, where am I? Okay, I'm here. We standardize, then we ask MATLAB to use K-means now to do the classification today. And in your template, I put, please define your classifier. I put it there for you. Then you have to change that. The first one you have to change is import your data, define your classifier. You will see the next thing you are going to change also. Now, remember now that, let me just do this aside. Now, remember the next thing you are going to do when you have a prediction or classification, you need to test, you need to check for the training. Now, I think I'll be using my slide now to walk you through. Now, you need to test for training. You need to look at your testing. You need to do testing and the training. You have to do that. I want to know the best method I'm going to use to explain this to you. Okay, what I'm going to do is that, let's first of all train. Let's train first. I think we should train first, because there are a few things I still want to. Okay, comment this. Everybody comment this. Comment it. Comment this for me. Comment it. Another way you can comment, everybody right click, you say comment. You see that? Right click, comment. You can comment. Okay, that's another way. I can just, instead of you wasting time, you just highlight everything. Okay, highlight everything and say comment. It's simple. MATLAB has commented everything. Do you see now? Okay. Now, what I want to do, I'm going to now, step by step, I'm going to roll this out. I'm going to run it. Call it title, then run. Now, he has run this for me with the model. Now, okay, we have gotten up to classification. Now, you see the classification here? That is your model. That is your model. You see now, he has done the classification now. He has run this. That is your model. Do you get it? Now, how do you test? I want you to test for your model now. Everybody, look at me. If you go to your, you want to check. You want to check your classification. Now, please listen now. We want to look at what does that classifier, what does it make as a default for modeling that particular parameter, that particular data. We want to see the constituent of it. And I'm going to give you some secret of how to play with the property and actually turn it around and be able to write a lot of things around, around the work alone. Now, look at what I'm going to do. I'm going to say classification. What you just copy this. Just copy this. It's easy. Copy this and come here, paste it here, and just run it. Now, if you look at the classifier, what he has done is telling you that model has particular all these properties. Predictor name. What are the predictor names? In other words, it tells you what did you use as a predictor. You've used age and you use estimated salary. Those are your two predictors. It gives you the property used to predict. The second one is that what are your response name? Your response name is ability to either purchase or not purchase. Are you with me? Are you following me?
Yeah.
Okay. Now, the next one is that what is categorical predictor? Do we have a categorical predictor? No, the answer is no, we don't have a categorical predictor. Because we don't have categorical predictor in our input. There are only two predictors we have, the age and the salary. Therefore, the categorical predictor is empty. Do Did you see that? Now, the next thing is that, what is a class name? The class name is your response name, which are not purchased and purchased. It shows you. Now, the next one is that, what is your score transform? You don't have that. It's none. Now, what is the number of observations? This is crucial. The number of observation of that data is 400. We use observation, and what English now? We use 400 observed data to process this model. That's what it said. Now, what kind of distance method do we employ? We use Euclidean. That's a default one. Oh. Now, here is a new paper. You want to write paper? Here is it. You have to play with it. You remember those one Prof told you? Prof, what that's French name again? Prof, what? That name that was difficult for me to call. Okay. That one paper. This one paper. Another one paper. Then you do the optimization of which best distance is the optimum. Which best distance method is the optimum? It's a query you need to check if it is correct. That's number one. Number two is the number of neighbors. That is something to trade with. Now, you have a data. You have a questionable data here. Now, you are telling me that I use this questionable data and I said it belongs to this just because here. That is not a good prediction. That is what MATLAB use. You only use one. Instead of, and I told you earlier on, minimum of what? 5. K must be 5. Do you get it? The default is one neighbor. Now, you have another thing to play with. You can start from 1, 4, 8, or whatever interval, and you'll be plotting your graph 1 by 1. Which one is optimal? You see now? Now, you can create a lot of title around here. I'm going to tell you how to play with this property now and change things. Then give you different results. And you affect the data and begin to train the rest. Okay, now you got it. Okay, let's move on.
Prof.
Yeah.
This number of observation, is it talking about the number of instances in the data set?
Yes, that's correct. It's number of instances in the data set.
Thanks.
Okay, let's go to our slide. Now, in our slide, the next one is that there's something that very important is to test of your model. Testing of your model is important. Now, keep something in mind. When I run this model with the entire data. Prof says something there. Prof, you remember what you said, that when you use the old data to train, now when you test, what happens?
Well, there could be problem of overfitting.
Correct. You cannot use your entire data to run your training. And now, the test. Now, I'm going to give you a trick of how to partition your data from the word before you train. Now, if we keep some data, like a new data, it doesn't touch it at all to train. That data has never been the history of it. What people normally do to play game is that they use the old data, now they take a game from their data and test. It's fake. It's 419. Because there's no true data there. Now they get 0.9 and you got 0.5 and you begin to kill yourself. No, they've done 419 on that data. Normally you're supposed to separate. You don't even talk. That data does not come to training at all. It has to. I'll give you one simple step of MATLAB code that separate that data by default. It will never come to training at all. That's why I want you to see the whole data that come to training. All of them came to that training. You can see it. Now, the first thing is that the following step needs to be followed. You have to do test and train set. Then you make prediction for the test set. Then you analyze the prediction. Now, what happened here is that for us to do that, MATLAB has something called CV partition. It's called CV partition. That's the function. Now, what it does here is this. You see, with a CV partition, you could see that immediately I pass a function called number of observation. I told you the number of observations for the entire data is 400. From a default one, you use all the numbers to do the training, which you shouldn't do. Now, what I want to do now, I want you to keep quiet on data I want to use for testing. I just want you to use a certain data, pure data for training, and a pure data for testing. That's what I want you to do for me. Now, I will use what we call a CV partition now, called classification. Where do I get this from? Remember, this is initial data I've trained. Are you following? Now, I will use that. Now, I will now say the number of observation. How many number of observation do I want? I want 20% to be kept for me. Now, there are different functions in MATLAB. When we come to performance analysis, I'm going to show you what happened here. We have something called odd out. We have what we call k-fold. Prof, did you teach us? I think in your first lecture you mentioned something on k-fold.
Yes, cross-validation.
We have odd out and we are k-fold. There are other ones. We are going to play with them. We are going to play with all of them. And you see how all of them can be manipulated to give you the best you want. Now, what happened here is that I'm going to just use odd out for this particular operation. Now, when I say odd out, in other words, odd out 20% of that data. Don't ever touch it to do anything. Don't train it, don't do it. I'm going to use it for my test. Now, that is the purpose of the odd out. And that's what happened there. Now, when I've done this, what I want to do is what we call a cross-validated model. I need to cross-validate the model. In other words, I pass the model, I pass the testing, and I check two of them together. And that's okay. How is now the model performing on my testing data? And that's the purpose of it. You could see that I'm now passing a CV partition. You see, I pass it back into here. I pass it back into function to be able to do the cross-validation for me on that particular data. That's what we are going to do now. Everybody, now go back to your code, remove the comment, and we roll it.
You have to comment the classification one.
You have to uncomment the text. You come here, you uncomment it, come here, say uncomment, and that's all. Have you done that?
Don't you have to comment the first one?
You uncomment it. Remember, here. Remember, I've commented everything below classification. Now, uncommented. Okay? Now, since we have uncommented, now, I want to make a prediction now. I want to make a prediction on what we've done on cross-validated model. Then I will uncomment this to make a prediction. Just uncomment it, right-click, say uncomment. It's the easiest way to do it. Did you get that now? Now, pay attention here. I did something very nasty, and you must watch it. Now, on this code, you see, I said prediction, predict. This is the function.
Yeah.
Are you following? Cross-validated is this.
Yeah.
I pass it here. Now, this is also a function. When we get to performance analysis of model, I'm going to tell you what this one means. And I pass a one in the comment. It's a default one. Then, if you do this without data, it will run as a test. We test the CV, which is this. It's testing this, that's CV. Are you following now? Now, when it tests that, then you see this comment, what it does is that when it gets, remember the data, I started with the heading, I started with that, it's going to remove that. It's not going to pass through the process. It's going to only take the data part and pass through. That's the purpose of that. Now, I've segregated so that you understand the script when you are working with it, so that you know if your data is already sorted, you will be fine. Okay, now, that is done. Now, just uncomment that, let's play with it. And uncomment below, uncomment this. Let's uncomment this. Uncomment that as well, so that we also explain this. Okay. Now, when you see this, what I've done, Prof was talking about how do you validate, how do you check if your result. We use what we call confusion math. That's a function in MATLAB. It's confusion math. And Prof said it's going to, I think you explained last time, confusion math. But when it comes to performance, I'm going to explain as well. Then he mentioned something on loss.
Loss function.
Loss function. Now we will talk about it. We will take a problem. Also, we will discuss that so that we see how MATLAB can. Then we have a confusion math. Then we pass this. You see this Y is where, now how accurate that prediction is. How accurate is it? Now we have to check the result. Remember, there is a result, which is a check the result, then you will return your cross matrix, or what do you call it now? Confusion matrix. Check your result now. Result. Result is 48. When you have a diagonal, this is a true value. This is incorrect prediction. That 7 plus 9 is incorrect prediction. 48 plus 16 is a correct prediction. That's a good one, isn't it, Prof? Is that bad?
Yeah, it is. It means for the first category, 48 plus 9, which is 57, it means out of 57, 48 was correctly classified, 9 incorrectly classified.
9 plus 7?
9 for the first line.
Oh, okay.
The second line, 16 is correctly classified, 7 is incorrectly classified. So,
do you get it now? That's a cross. Do you see that? That's how to discover what is the performance. Okay. I'm going to show you different performances. This now goes into your paper. It comes there to show the performance of the KNN. Do you get it now? That's how to build the paper. Now, when you get home today, go and look at all the paper I gave you. You will see all this now. They'll be mentioning all those things. Then you'll be used to them. You understand them now. Now, if you are working on a data on a cattle in Mpumalanga, then you take your cattle data, you plug it in here, you interpret it with everything he gave you here. Isn't it? One have never changed from 1. 1 plus 1 is still 2. That have never changed. Now, it depends on who says it. Now, it's what is different. Okay. Okay. Now, are you getting it? Are you getting it? Okay. Now,
next Saturday, we're going to talk more about training, as well as confusion matrix, precision recall, all that.
Yeah, it would be nice if you train them with that, because I also do a lot of them in performance analysis, so that we apply it on the real problem. We see different method, how it works, and how the performance analysis go. Okay. Now, come to something that always interests everybody, is the visualization of your result. How does your result look like? What is the visualization of it? Now, this one I'm going to explain, but if you are in my former class, my MATLAB class, you will have gotten all this syntax right. Okay? But I'm going to explain as much as I could do. Okay? But if you are not there, I think you can ask the young ones to put you through. Now, what happened here is that under visualization, you could see that I put a label with a unique data for the purchase. You see, the label, with Prof mentioned about the label earlier on. Remember my label, the outcome or the target is my purchase. Are you following? Now, that is my unique data. Unique in the sense that it's a categorical for me. Because I don't want him to use number, then I make it unique. Therefore, the classifier, remember my classifier is my K nearest neighbor. Are you with me? Then I pass in the training result. I pass in the training result to it. The next one is the age range. Are you with me? The age range now, I want to use the age range. I want to visualize the age range with the estimated salary. And what I've done is that I want you to do this for me, plot the graph at the interval of 0.01 resolution from both extreme end and to the minimum end. And that's what I was doing there. Now, then I want to use a mesh grid to plot all the graph. Now, let's make it nice by going through each of them one by one. I want you to uncomment this up to here, uncomment it. Let's roll this out and see what we are going to get. Let's just roll it out. It might take some time. Look at what it gives me. Did you see the output? It gave me that. Not purchase and purchase. Did you see that? Then it gives me the purchase boundary are all here. Not purchase are this grid. What is it telling me? I don't have a lot of information on it now because I don't have data on it. What I have plotted is the map of the boundary. I've not put in the prediction into it. I've not put the test into it. Are you with me? Now I want to put the test and the prediction into it now. Are you with me? Now see what I'm going to do. Now, what this one means, remember in MATLAB, I told you last time, when you hear the word hold, you should hold on to the graph, isn't it? Remember. Let's uncomment that. Now, what we're going to do, let's also uncomment here. Uncomment this as well. Okay? Uncomment that. Or we can actually, okay, uncomment that. Uncomment that. Now, what I want you to do now is that I've said that, okay, trend data equal to that. Now, you should pass this now. Now, I want to plot it, I want to roll it again. Just watch what's going to happen. Now, he has positioned the data for me. Do you see that? Now, it tells me where is the position of those people who can purchase and those who cannot purchase, with all those particular information of the boundary. Are you with me? Now, that is the training result. That is my training result. Now, let's visualize now the testing result. Okay? The testing result here, just uncomment this. Testing result, downward. Just uncomment that straight away. Then now, let's plot everything and see what we get. Then, I carry out the explanation. That's a testing result. Deciding training result. Now we have that. Now let's give explanation to it. Now, what you notice here is that we have the estimated salary against the what? Purchase or no, or against the age. Estimated salary against the age. We plot it there. Now, this can actually give you some interpretation. If you look at this, when the salary is R, people have more purchasing power, isn't it? They can purchase. You see, they can purchase. Is that not correct? And when people are growing older, what happens? You have saved. You don't have a lot of mortgage like me. I'm swimming in mortgage because I'm young. By the time I'm growing older, all my mortgage will have been paid for because maybe 20 years mortgage, 50 years mortgage, everything will have paid for. Then I have excess money with me. This is what this graph is telling you. Then I have more purchasing power. Do you get it? And when my age is older, I have more purchasing power. This is what it said. And when my salary is high, I can buy so many things with the salary.
No more school fees to pay.
No more school fees, nothing to pay again. It's just you and your wife, you fly all over the world and go for holiday. That's what you are meant to do for the rest of your life. Every mortgage has been paid for. I don't know why God it should be reversed. When you are growing younger, you should have a lot of money. When you are growing older, you should be smaller because now you are going to go to graveyard very soon with so many money. You don't use them.
If you have big salary, even when you are young, you see how purchasing power.
Guys, are you tired? Prof is telling me 5 o'clock now. We just finished one part. It's left to you if you want me to stop. I will stop when you start. Now, did you see? Otherwise, if you don't stop me, Prof, if you don't stop me, I'll just continue. Now,
you know you are younger, so your energy is there.
Okay, Prof, you want to have?
No, go ahead. I just want to write something.
Okay. Now I will stop.
Oh, okay. There's no need to write. Okay. Please, for next week, if you want, Google Waker. It will take you to a website in New Zealand, University of Waikato. Download the tool, Weka tool. When you get to the download, you have different versions. The current version is 3.8.3. And then for that you have two versions. You have the one that you can install on 64-bit architecture. I hope I'm speaking in plain language here. 64-bit. Majority of the new computer that we have today, they are 64-bit architecture. Now, if your computer is old, you will see 32-bit also architecture. So pick whichever one fits into your laptop, download it, install it, and then next week, next Saturday, we're going to look at that. Also, we are going to try through Professor Pios to see if they can put the image on the computer here. I think if they can do that, that will be easier for everybody. Another thing you will notice when you go there is that for each of the architecture, you have two versions. One version comes with the JRE, the Java, okay, the other version doesn't come. I would suggest that even if you have Java installed in your computer, download the JRE one, because at times the version of the JRE is important. Anything below version 8 will not work well with that Weka, okay? So that's just it. If you check that website very well, there are a lot of documents on the website, and some of the slides that I'm using for the what is it called, for the mathematics side, you can find some complete slide on that website too that give more information on that. Okay, so it's part of what we're going to look at next week.
Okay, thanks, Prof. I think the Prof said is okay. I think if you, are you guys tired as well?
Yeah.
Okay. Because you are not.
We continue next week.
Okay. That's okay. Because I thought I would be able to play with distance with you guys, so that you see the neighbors, how when I alter those neighbors, what happened to them. Okay.
You can finish this one then. Just complete
Please, continue.
Okay.
We agreed to, it's not yet 5 o'clock.
Okay. Now what? Okay. What I want to do now, then I will try to rush you. What I want to do is to look at the property that I told you. I want you see, we've plotted the default now. Okay, we've used the default. I want to modify the property to give me a better result. Now, what I want to do, I've also make it easy for you. There are two ways to do multiplication with a property. There is before building the model, and there is after building the model. Are you with me? Now, if you want to go with before building the model, sorry, can you say? Okay. Now, there is before building the model and after building the model. Now, before building the model, what it means is that you will have incorporated all your properties into the model. Like, remember, classification model fit KNN that. All the property, if I want to have 10 neighborhood, I will put it there. I want distance to be Euclidean, I want it to be, before I build the model. The other one is that after I build the model, I can still manipulate the predictor itself. But there's a limitation to that. Because there are some property that will be inactive. They are not going to, they are private. They are not going to be available to you anymore. After you've done the model, they will be private. You can only do wonder when before the model. You have a less wonder to do after the model. Now, if you want to modify something after the model, this is the way to go. Remember, you compute your model, then you send the classification model 1, in other words, you create another classification. You now say it's equal to this classification. Now, what property do I want to change in the new model that I want to create? I want to change the number of neighborhood. It will be dot number of neighborhood. By how many? I want to add 10. From 5, I want to go to 10. Then you pass that. Then you compute it. Then you change the property from 5 to 10. Anything you train after that is using 10 neighborhood. That is after. But I don't like using after. At the worst case, if I know I'm really lazy, then I will use after. But if I'm not lazy, I will use before. I will have planned my model from here. Okay, now let's do that before and after. And now I want you to now correlate that with your result. What are you going to get? How is your result? Now, one thing I did not tell you earlier on is that I think I should do it now so that you see, so that you can put your eyes on something. Look at this. Look at these two. There are noises. What happened now? Can you see this? But why is okay? Maybe because I've made the PowerPoint to okay, let me just make it quiet. Now, what I want you to look into is to look at this. You see how many noise we have. You see what this one means is that this is a wrong prediction. Wrong prediction. You remember the result we showed you earlier on? That cross matrices or whatever. You see, those are the wrong prediction. Now, when you improve the properties, you expect this to give you a better performance. That is what we want to do. We want to improve on this result. Now, let's go in your, if you check your, I want you to go into the code. I've already also done it for you. Go to the next slide. You see build before and build after. Did you see that? Let's work on build before. Okay, we want to change the property based on build before. Open that. Copy that now and change your data. Remember, you are only changing your data. Okay, copy that. Go to. You sure next time you must tell me not to teach you anymore because I will take time. That's the problem with me. Yeah, I don't have. Last time my students have to run away from. They told me that they can't cope anymore. And I'm not feeling it. You know, I can only feel it when. Now change this, okay? Pass this and change this into it. Then we will roll out that one that shows before. Paste that link so that you have that data. Okay. Now I want you to look at something. Why is it before? What I've done before, you see. Remember, this is a distance. I've changed it to city block. Prof, you remember city block?
Yeah.
Yeah, I've changed it to city block.
City block, yeah.
Now, let me now give you where the secret is. Okay, where the secret is here. Go here, go to this place, type feet. Then press enter. Type feet. Yeah, good. I'm going to show you one simple secret now that you need. Now, go to fit KNN. If you see it, let me know. Fit KNN. I'm looking for fit KNN. Did you see it? Why am I not seeing it? Okay, let me do this so that it will reduce to classifier. Alright. Is it not fit? What code are we using? Fit what? Not fit KNN.
Search fit KNN.
Is it? Yeah, it's supposed to give me fit KNN.
Yeah.
Okay, good. Lucky me. Okay, brilliant. This is where the whole secret is. All the secrets I've been keeping for you, they are all here. Now, what I want to see, Prof talk about go to what can I tell you to go to? Okay, come here. Come here. Go to distance. I'm looking for distance. Input argument. Let's go to input argument. Is it making sense? I need name value. Name value. Okay, name value. Good. This is where all the properties you can actually write paper on. They are all here. All the property. Remember I told you about K-fold? Did you see that? K-fold is here. Leave out. Did you see that? Number of neighbors. Did you see that? Predict name. I'm looking for distance. You see the odd out. Did you see the odd out? If you want to know anything about them, they are all here. Did you see that? Now I'm going to go to distance so that you can see the opportunity that is there. Okay, I think here we go. Here we go. It should be down, I guess. Oh, this is where I say you will write paper. Did you see that? That's what you have been going to be changing. Shade, correlation, cosine, median, army, japa, Now, let me take you to the code. Here is the code. You'll be changing this. One line. If you know spelling before, if you don't know, just change that, roll it. Change that, roll it. Change that. Are you okay?
We are okay.
You are not okay. Now you see the answer on the board and you say you are not okay. Now look at this.
You will change that.
Look at it. This is Euclidean. Remove that and put Euclidean there. Remove that, change it to this. Remove that, change it to this. Let's just take one that we don't even know before. I don't even know this, but let me use it. If it doesn't make sense, it's okay. I'll copy that. I'll go there. I'll replace this. I'll paste it. I'll compute it. I'll roll it. And it give me another result. Some can be computational intensive. See, it's give a different result. See, it better improve one. You see that? Then I'll compute the cross validations also. I'll type the result to give me what is the performance. Then I record that. I change the distance again. I compute the result. I put all of them in a table. A paper of standard for you. Clear, simple paper. You interpret them. You see how life is easy? Eh?
Yeah, I think if you can just master the skill of interpreting.
Are you okay now? Now, those are the property that you'll be changing. And I put the one before and after there for you to play with. Sorry? Am I still recording? Yeah, I record it on. I have OB. Because I'm not going to teach any student again for the rest of my life. Just give them this video. I'm going to teach another thing. Okay. Now, do you understand this? Is it clear to everybody? Yes. When you are coming next week, pumping your data into it, I want to see graph from your research. Now, write a paper now on KNN on your work. People are predicting a stock exchange, predict it with it. People are predicting credit risk, predict it now with it. People are predicting weather, predict weather with KNN. And let me see how it looks. Do you understand? I don't think I can teach you more than this because I'm supposed to go to the next one, naive based. But next week, as Prof have stopped me, I will stop. Because today is weekend.
You need rest,
I'm going to be here tomorrow, Prof, from morning to night.
Is it?
Yeah.
Are you not going to church?
Yeah.
Yeah, I'll go to church, Prof. Okay, I think that should end the class for today.